My name is Sandra Valtero, and I'm your host. This evening, we are talking about emerging infectious diseases. And tonight, my two guests are, next to me, Dr. Alfred DeMaria. Hi, welcome. And next to him is David Henley. Dr. DeMaria is the medical director and state epidemiologist from the Bureau of Infectious Disease and Laboratory Services at the Mass Department of Public Health. And David Henley is the superintendent of East Middlesex and Suffolk County mosquito control projects. And Mr. Henley has been working in mosquito control since 1974 and became a superintendent in 1982. He is responsible for 26 cities and towns. Welcome, gentlemen. Be Prepared tries to present programs on health, wellness, and safety. And today we're going to talk a lot about mosquitoes and ticks, which is a very important issue. Would you like to start, David?
Sure. Well, I'm, as I mentioned, manage the East Middlesex Mosquito Control Project, which is the town of Burlington is one of the participating towns within our district. And so we provide a program to Burlington that includes mosquito surveillance. We measure the population. We have some of the mosquitoes in Burlington tested for West Nile virus and Tripoli. We provide a larval control program, which includes a helicopter application of BTI granulars in the spring. We also apply BTI to other wetlands during the spring and summer. We try to control Culex mosquitoes that could transmit West Nile virus, and so each year we try to control about 4,000 catch basins by applying larvicides to catch basins. We also, when mosquito populations are high, we do spraying around Burlington with truck-mounted aerosol sprayers.
So how do we identify those larva controls? Do you have a picture of that for us?
Sure.
Can we see that? That is
slide number 4.
Slide number 4. I'm afraid they're not ready. Also, you also have catch basins and neighborhoods.
Right. So our larval control program is two things. First, we control spring floodwater mosquitoes in April. Each year we put a helicopter over the Vinebrook swamp. Then we have our crew will go to smaller wetlands around Burlington, and with both the helicopter program and the crew walking around wetlands, we use a pesticide called BTI, which is a biological material. We also continue that program of at least walking around wetlands if there are any flooding summer rains, something that at least for the first half of the summer we haven't had any problems with. And then in Burlington there are at least 3,000 catch basins, which are storm drains that take roadside runoff following rainstorms. And so we treat those produce Culex mosquitoes, which are the main vector for West Nile virus. And so we have people that go around Burlington on bicycles and they drop a packet of larvicide into the catch basin to control them. So,
and does that work?
It does.
Yeah.
It does. We monitor for everything that we do before and after surveys to test how effective it works.
So we're in good control here in Burlington, at least.
Well, we do what we can. I mean, there are problems, like in there's one mosquito species that develops in the Vinebrook swamp and in permanent water marshes that we can't control with larvicides. It's called Cochleartidia perturbans, and it hatches out every year between mid-June and mid-July. So for that mosquito, we actually have to wait until it hatches out into its adult stage and then do neighborhood spraying. The good thing in Burlington is that it's really only in the the area around the Vinebrook Swamp and in the southwest corner of town. That's where the permanent water marshes are, particularly marshes with cattails in them.
Oh, I see. Okay. Now, in the spraying, does that affect the people adversely in any way?
So we use a pesticide product called Anvil 1010, which has the active ingredient of sumethrin in it. And the basic principle is that we're trying to control something that's the body weight of a mosquito. And so we're actually applying it as an aerosol at 0.0024 pounds of active ingredient per acre. And the difference between the weight of a mosquito and even the weight of a baby or a person is just immense. And so sumethrin is not a carcinogen, and it's actually classified as a slightly toxic material. It's the pesticide that the state uses in aerial applications in southeastern Mass when it does Tripoli spraying, and they've looked at the possible human health impacts of the pesticide and the non-target impacts of the pesticide, and they chose Anvil 1010. So it shouldn't cause a problem with people because it's people are so much larger, and there's a big thing. There's a research article that was done that compared the risk of mosquito management pesticides to the actual exposure that people would get. And they looked at what the EPA determines as a reference dose, and that is the amount of exposure that would actually cause an impact to test animals. And in that, they found that the rate that sumethrin is applied, or Anvil 1010, is there's nothing within 1/1000th of that reference dose. So there's a really large margin of safety with it.
That's good to know. That's good to know.
Right.
Yeah. How much of a risk are we for West Nile and Tripoli here?
Well, actually, there is a risk. We get there have been, I think, 128 cases of West Nile virus since the first case occurred in 2002, and generally most cases happen in either urban or densely populated suburban areas. So there have been some human cases that have happened in Woburn and Lexington, and so I think that each year there's a local risk, and you just have to hope that it's not an unlucky year. Now there has never been a case in Burlington, but there's certainly a risk each year, and there's particularly a risk during abnormally hot periods, or the two environmental factors that contribute to the risk of West Nile virus are abnormally hot periods during the summer and dry conditions, which is kind of counterintuitive. You'd think that wet conditions would produce mosquitoes, but in fact the vector of West Nile virus, a species called Culex pipiens that develops in catch basins and water holding containers, does much better in highly organic material and highly organic water. And so when the water just sits there for weeks at a time, it builds up an organic material, and so it makes conditions better for that species.
I see. So, okay, and is that the same for Tripoli?
No, Tripoli comes from a mosquito that develops primarily in white cedar swamps and to a lesser degree in red maple swamps. There used to be a cedar swamp in Burlington by Beacon Street, but that was actually kind of decimated by development, I think, a long time ago. I mean, I think, well, I'm not sure when, but so there are some cedar swamps in this area in Reading, North Reading, Bedford, and Sudbury, but really the prime risk area for Tripoli is in southeastern Massachusetts, where they have really extensive acreage of cedar swamps. And so a cedar swamp produces a type of mosquito, Culecida melanura, that essentially amplifies Tripoli, it spreads it around in the bird population. And then at times when there's a lot of amplification, another mosquito species will bite an infected bird and then bite a person. I mean, this year so far, we're at a fairly low risk for Tripoli because it's a dry year. So Tripoli tends to do better when we have long periods of wet weather, or several months in a row of wet weather.
Right.
And that produces this mosquito, Culcida melanura, in cedar swamps.
Okay. So what about these are adult mosquitoes, different than, it's more at risk when they're adult than when they're babies, is that?
Sure. Well, could we show the slide on the mosquito life cycle, which is slide number 2?
Slide number 2.
Okay. So you can see where this is the top cycle is a picture of mosquito eggs, which are really very difficult to see. They kind of look like little black dots in the water when you see them. And then the when the mosquitoes emerge from the larval stage, or emerge from their eggs, they go into the larval stage. Now, depending on the species, during the hot weather in the summer, it may take them a week to go through their larval stages. And there are some species where, particularly the mosquitoes, the Coquiltidia perturbans that develop in the Vinebrook swamp, they spend 11 months in the larval stage. The mosquitoes will molt into their next stage, which is a pupal stage, which is a non-feeding stage. And they're usually only in their pupal stage for a day or two. And they don't feed during that stage, and then they emerge into their adult stage. Their adult stage is the only stage where they can actually like pick up a virus by, in this case, West Nile virus of Tripoli, by biting an infected bird and then transmitting the virus to people.
I see. Okay, good. So mosquitoes can spread Zika virus also? Dr. DeMaria? I'm sorry, DeMaria?
Yeah, Zika virus is just another virus that mosquitoes can transmit. And the public health concern is with whether it's mosquitoes or ticks. The public health concern are these diseases that they can transmit. And people need to understand that all of these infectious agents have a life cycle in the vector, in the mosquito or the tick that transmit them. So they're not just transmitting infected blood from one person to another. The organism that's causing the infection is having part of its life cycle in the mosquito or in the tick. So it's a complex interaction that occurs. And there's West Nile virus and Tripoli virus transmitted by mosquitoes here, and there's a whole slew of infections transmitted by ticks in Massachusetts. And now we're considering the potential for Zika virus. We could consider dengue virus as another one, chikungunya, that have also come to the Western Hemisphere, and are a risk, but for the reasons that West Nile is transmitted by specific mosquitoes under certain circumstances, and Tripoli is transmitted by certain mosquitoes under certain circumstances. These viruses are transmitted by mosquitoes that bite humans. So the Zika virus, the yellow fever virus, the dengue virus, chikungunya virus are in the human bloodstream, not in birds. And fortunately, at least for the present, until the world gets a little warmer, we don't have the kind of human-biting mosquitoes that transmit those infections. So we really don't expect to see those transmitted in Massachusetts.
That's good. Very good, yeah. So why then is it a tick-borne disease is such a problem here?
Well, tick-borne diseases is a problem because we've created the perfect environment for the black-legged or deer tick, Ixodes scapularis. And maybe we could show the life cycle of the tick, very similar to the mosquito. It has a life cycle, it has different stages. The eggs are laid, and the eggs hatch into larvae, which hatch into nymphs, and then the nymphs hatch and molt into adults. And for each of those stages, they have to take blood. So they take a blood meal. And when they're larvae, they can take a blood meal on small mammals or birds that carry the infections that we're concerned about. And these infections can be Lyme disease, a parasitic infection, babesiosis, a bacterial infection, anaplasmosis. People may have heard now about Powassan virus, another one, and then there are even several more that the ticks can transmit. Now these ticks are not insects. Insects have 3 body parts, a head, a thorax, and an abdomen. They have wings, and they have 6 legs. Ticks have 8 legs, therefore they're more closely related to spiders. And they don't really have they only have 1 body part, and it's the tick. They don't have a head, they don't have a thorax, they just have an abdomen. And all they do is take blood and reproduce. So, and they take blood in a different fashion than the mosquito. The mosquito lands on you and puts this little needle-like proboscis into a blood vessel and sucks blood. Whereas the tick actually has a little mouth part that causes bleeding. And what happens is the tick gets engorged, but that takes a number of days.
Oh, really?
So when we talk about prevention, one of the most important parts of prevention is to remove the tick before the organisms in the tick have time to wake up and cause infection, because they're actually dormant in the tick during the time, between the time the tick takes its blood meal and the time it takes another blood meal, because the life cycle is 2 years. So unlike mosquitoes, who can be taking blood every 2 weeks or even every week in hot weather, the ticks only take a blood meal roughly once a year. So while they're not actively feeding, the organisms in the tick go to sleep. And they don't wake up until the tick attaches. So that's why it's very advantageous. If you can't avoid the tick, the best protection is to avoid the tick in the first place. But if you can't avoid the tick in the first place and it attaches, to do a tick check and then remove the tick. And you can see how small the ticks are. The nymph, which is probably responsible for 90% of the infection that gets transmitted, is only the size of a poppy seed. And that's very small and hard to see. The adult is a little bigger, the size of a sesame seed, but even that's pretty small. And in their mouth parts, in their saliva, they have anti-inflammatory agents, they have anticoagulants, so they keep you bleeding, and they have an anesthetic, so you can't feel them attached. So all of those mean you really have to look for them. And what they do is they jump onto your clothes, onto your body, and they try to find a warm, moist part of your body, because drying is the worst thing that can happen to a tick. And that becomes important when we talk about prevention too, because by putting them in a circumstance where they can dry, you can actually get rid of them. So whether it's a dryer, putting your clothes into a dryer, or it's putting mulch or gravel around your house so they can't cross the dry part of the landscape, then you can prevent them from getting onto your property. But what they want to do is they want to attach and take a blood meal. And the larvae don't really feed on humans too often, and they're not infected yet because they have to take their first blood meal to get infected. So the larvae can get infected on small mammals and birds, and the nymphs can get infected on small mammals and birds, and that's how they acquire their infection. The adults don't molt because they're an adult already, but the females really need to take a blood meal to lay their eggs. So on average, they're taking 3 blood meals, and they try to take one blood meal on one individual. So if you get them off
Within a certain length of time?
within 24 hours would be
You have 24
24 to
hours.
36 hours before the infection. Now, Powassan may be a little different, but fortunately, it doesn't seem to be as prevalent yet. But we really are having an enormous amount of problems with tick-borne disease. We have a reported 3,000 to 4,000 cases of Lyme disease every year, but that represents about 12,000 people we get reports on who don't meet the definition because we don't have enough information
Right.
about them. And the CDC estimates that there are about 10 times as many cases that actually get reported. So we may have 30 to 40,000 cases a year. And now we're seeing marked increases in babesiosis, marked increases in anaplasmosis, and these can be life-threatening
Yeah.
diseases. And then we're watching out for newly emerging, like powassan, like something called Borrelia miyamotoi. It's amazing the capacity of these ticks to transmit. And the reason that it's become a problem is because we've suburbanized the environment. We've created the ideal environment for deer, and the deer carry the ticks. They don't carry the infection, they carry the ticks.
Right.
And we've created a fragmented forest around our homes, which allow the field mice, the deer mice to reproduce in large numbers. They carry the infection primarily. So the ticks can get carried on the deer and spread around. They then get into the leaf litter. They have to stay under the leaf litter to stay moist. And they can then bite these small mammals, acquire the infections, and then attach to people. And that's where the problem comes. And we've sort of created this circumstance by our lifestyle, like many emerging infectious diseases. It's how we live, what we eat, what we do that lead to this. And in this case, it's how we've changed the environment.
Mm-hmm. So weather has an influence on it too.
Weather has an influence in terms of climate, not day-to-day weather. Now, in the winter, if it's a very cold winter without snow, the ticks can get dried out over the winter.
Mm-hmm.
But if there's a nice snow cover for them and it's not that cold and the air is not that dry, they can overwinter. In fact, on a warm day in February, the adult ticks can come out and start attaching to people. So
After a certain
you can
yeah.
get these infections any time of the year, but the prime time is April, May, and June, because that's when the nymphs come out, and the nymphs probably account for 90% of all the infections, and we see that when the reported cases that occur in June, July, and August. But we get cases in October, we get cases sometimes in the spring.
Yeah.
So you can get it any time of the year, but the prime time is those 3 months when those nymph stage ticks are out seeking their blood meal.
And that's when we have to protect ourselves.
Well, you have to protect yourself all year
Yeah,
because
but
you can still encounter ticks any time of the year. But it's very important to use, first of all, to do as much as possible to avoid the ticks in the first place. Avoid ticky areas, and that's sort of the scrubby areas with the high plants. If you stay in the middle of the path, you're not going to encounter ticks. If you're going to go into that area with the shrubs and the high grass, then you want to wear long clothes, tuck in your pants, do those things. That's hard to do when the temperature is 95 degrees, 100% humidity. So you have repellents, and there are several products, and if you go on the Department of Public Health website, you can see what those products are and how to use them. It's important that you use them according to the instructions because they don't last all day. I think people think you can put this on in the morning and you're all set for the day, but you might have to reapply some of these products more frequently. And then to do that tick check after you come indoors. Many people in areas where are hard hit by tick populations and these infections, people will come in, take their clothes off, and launder their clothes or dry their clothes to get rid of the ticks, because you can bring them into the house as well, and they can attach. So there's a lot of things we have to do now that we didn't have to do 20 or 30 years ago, just because of the numbers of ticks that are now present.
Now, do they cling to you so that if you come in, you take a shower, like for your back, you can't see your back if they're on there? Would a shower wash them away?
They will if they haven't attached yet. So they stick their mouth parts into the skin, and they go like this constantly to cause you to bleed. You can't feel that. But before they attach, they're sort of crawling around. And yes, showering can help. And getting those clothes that might be carrying ticks can help. And checking your pets when they come in, because they can carry the ticks. Inside, they can get some of these infections, so that's important to do as well. And then there are things you can do in your environment, in your yard. As I already mentioned, you can have barriers that prevent ticks from getting on your property. You can landscape your property in various ways. And there's a wonderful manual from the Connecticut Extension Services, the Connecticut Agricultural Extension, thank you, that can guide you on what you can do. And you can also get a licensed pesticide applicator. Now, it's different from the mosquitoes. The mosquitoes are flying around in the air. They're not in the leaf litter. So it presents a little different problem than mosquito control,
Right.
because their whole life cycle is sort of hidden under the leaf litter.
Yeah, so we have to watch for so many things. I understand, is that true? The Iceman had,
Yes, the Iceman,
had Lyme disease?
I think it's 5 or 10,000 year old
Yeah.
man found in the Alps. It turns out that among other things, he had Lyme disease.
Yes, and interesting, huh? And what about the Zika? How is that passed? Is that passed through milk also?
No,
like,
no, well, no,
breast milk?
actually, we don't know yet.
We don't
So
know yet. Okay.
We're not sure. What we do know is it's passed by mosquitoes, but they have to be mosquitoes that bite people, so they pass it from person to person. The mosquitoes that transmit West Nile and Tripoli among birds are primarily bird biters. They'll occasionally bite people. So that's why we have between 5 and sometimes in a bad year 30 cases of West Nile and 0 to maybe 5 cases of Tripoli, because the mosquitoes that transmit those would rather be biting birds than us,
see.
but they will bite us, and there are bridge mosquitoes that do that. The problem in more tropical or even semi-tropical areas is they have these Aedes aegypti mosquitoes and Aedes albopictus mosquitoes that preferably, Aedes aegypti preferably bite people. So they're moving the virus from person to person and allowing the virus to, as I said, the virus has to reproduce in the mosquito. So you have to have a mosquito that can reproduce the virus, and you have a mosquito that is likely to bite the source of the virus and people, and that sets you up. And we're not really set up in Massachusetts for that. We have a few Aedes albopictus now in Massachusetts, but we really don't have the numbers of people infected. We have travelers who come back infected, but we don't have the large numbers to make it probable
Right.
that the mosquito will encounter a person with infection. And then we don't have a large number of these mosquitoes to maintain the transmission cycle. That may change with global climate change, because what
Right.
we're seeing is these mosquitoes are moving north. So albopictus is arriving now, and we have in the past, when the climate has been different, we have had Aedes aegypti in Massachusetts back in colonial times, spreading yellow fever. So we know that's a possibility.
That is scary. Well, we're running out of time. One last comment, David, about mosquitoes you'd like to make?
Well, you might want to put a picture of the Aedes albopictus up. So we've actually been looking for Aedes albopictus for the past few years. That's slide number 8. So we've been looking for Aedes albopictus for the last couple of years. We found one in Boston in 2014, and the feeling is that was a hitchhiker that came up on either a truck or a train or a ship. It's a very easy mosquito to identify, and it's eventually supposed to be here because of global warming, but it's not here yet. And so
Thank
one of our roles is just to look for it.
Okay. Well, thank you. We have to be warned. I'm sorry we have to cut you short. There's so much we can talk about, and I understand you're going to be able to come back and we can talk a little bit more next month on this. So, and I think Dr. Kramer hopefully will be able to join us then. All right. So this has been Be Prepared, and we are sorry that we can't fill you in more on this difficult situation with our ticks and mosquitoes, but we have a lot of good people working for us to help protect us. And next month, hopefully, we'll give you more information about more emerging diseases that we are working on and that we need to be watchful for. So my name is Sandra Voltero, and this is Be Prepared, and we'll see you next month, and thank you for joining us.